We are going to discuss method 4. In this particular case, we are going to discuss that when the points x1, y1, z1, x2, y2, z2 are divided into subpoints. So here we are having the problem if f bar is equal to x square minus 27 I bar minus 6yz j bar plus 8xz square k bar. Then we evaluate line integral f bar dot dr bar from the point 0, 0, 0 to the point 1, 1, 1 along the straight line from the point 0, 0, 0 to 1, 0, 0, 1, 0, 0 to the point 1, 1, 0 and the point 1, 1, 1, 0 to the 1, 1, 1. Here we are seeing that f bar is given, no plane equation is given in this particular condition. Initial point it is started from 0, 0, 0 to the terminal point 1, 1, 1. Between these 2 points they are divided into 3 cases here. From initial point it was moved to 1, 0, 0 and from 1, 0, 0 it was moved to 1, 1, 0 and from 1, 1, 0 it was converted into the terminal point here. So now going to the solution. Given f bar is equal to x square minus 27 I bar minus 6yz j bar plus 8xz square k bar. We know that r bar is equal to xi bar plus yj bar plus zk bar. Since there is no plane equation, we will be converting the total equation in terms of x, y, z. We are taking the derivative of second equation. dr is equal to dxi bar plus dyj bar plus dz k bar. Moving to the points, given initial point as 0, 0, 0 up to your terminal point 1, 1, 1. So between these points, they are divided in 3 cases here. Coming to the case 1, it is divided as from 0, 0, 0 to the point 1, 0, 0. And the second case, it was converted as 1, 0, 0 to the point 1, 1, 0. In case 1, whatever the terminal point is given, it is started for the initial value in case 2. Similarly, whatever the terminal point is given for case 2, it was started for the initial point in the case 3. So here in the case 3, we are having 1, 1, 0 to the terminal point as 1, 1, 1. Now we are going to convert the line integral according to the cases here. So the line integral we have divided into 3 cases as on the curve C1, on the curve C2 and on the curve C3. For our convenience, we have taken these integrals in the form of I is equal to I1 plus I2 plus I3 and we have denoted y is equal to in line integral f bar dot d bar. I1 is equal to on the curve C1 integral f bar dot dr bar. I2 is equal to line integral on the curve C2 f bar dot dr bar. I3 is equal to on the line integral C3 f bar dot dr bar. Now we are going to find the line integral I1. Here we know that I1 it is given as f bar dot dr bar. We are substituting f bar and dr value. On simplification of your dot product, we will be getting the equation as I1 is equal to on the line integral C1 x square minus 27 into dx minus 6yz into dy plus 8xz square dz. So in this particular case, the line integral either should be converted in terms of x, y, z. So here we are having the point as 0, 0, 0 to the point 1, 0, 0. In the method 3, we have discussed that when 2 points are given, we will be converting into the line equation form and we convert into the parametric equation here. But here we are not applying distance equation. Directly we are converting into the any one of the variable. How we are converting? Let us see. So here we are having y and z in the second point. From both the points we observe that y and z values are same. In the from the first point y is equal to 0 and from the second point y is equal to 0. Since both are same and z is equal to 0 in the first point, z is equal to 0 in the second point. Since both the conditions are same for y and z and x varies from 0 to 1. Since x having different values, these different values can be converted in the form of limits. Means the equation 8 will be converted totally in terms of x by substituting the limits of x as 0 to 1 and we can substitute y is equal to 0 and z is equal to 0. We require the dy and dz value. we are getting y is equal to 0 and z is equal to 0. We will be finding the derivative from that particular point. Y is equal to 0 can be written as dy is equal to 0. And the point z is equal to 0, on differentiating we get dz is equal to 0. Now we are going to substitute this equation 9 in equation 1, equation 8 by converting the limits as 0 to 1. Total equation is converted in terms of x. Here on simplification we got line integral 0 to 1 x square minus 27 dx. On integrating we get x cube by 3 minus 27x. Now we apply the limits. Limits should be applied as upper limit minus lower limit. In place of x you substitute 1 for the upper limit. In place of x you substitute 0 for the lower limit. On simplification we get I1 is equal to minus 80 by 3. Now we find out the second case for I2. Again we are substituting f bar and dr bar by using dot product. On simplification we get line integral c to x square minus 27 dx minus 6yz dy plus 8xz square dz. Again we will be converting this total equation in terms of single variable without applying distance formula here. We will be seeing that in the given points, if you are having the common point from the both points, you directly make it the point substitution here and find out the respective derivatives. Where the variable having the different points, that point will be converted in terms of limits. For the second case, we are having the points as 1, 0, 0 to the point 1, 1, 0. Means from these 2 points, if we observe x is equal to 1 in the first point and in the second point we are having x is equal to 1. From both the points we are having the common value of x as 1. So you can make it wherever you are getting x, you can substitute x is equal to 1, find out the respective derivative of x. Next, you are having y is equal to 0 in the first point and in the second point you are having y is equal to 1. Means we are having the difference for y value as 0 to 1. So you can convert your limits as in terms of y as 0 to 1. Means the total equation will be converted in terms of y value here. In the first point we are having z is equal to 0 and in the second point we are having z is equal to 0. Here also we see that z is equal to 0 is common from both the points. Means x is equal to 1 and z is equal to 0 are common. Means we will be substituting x is equal to 1, z is equal to 2. So z is equal to 0 in the I2 integral here and y varies from 0 to 1. So we will be finding the respective derivatives. For x is equal to 1, dx value will be equal to 0 since 1 is constant here. Z is equal to 0, derivative dz will be equal to 0. And we are having the y limits as 0 to 1. We will be substituting this 11 in equation 10. On simplification, you will be getting, since we are having the values of dx and dz equal to 0, we will be substituting the values and you substitute x is equal to 1, z is equal to 0. On simplification, we got I2 is equal to 0. Moving to the third case, we are having to find out the line integral I3. Again, we are substituting f bar, dr bar. By using your dot product, we are getting the equation as x square minus 27 dx minus 6yz dy plus 8xz square dz. Again we will be converting either in terms of x, y, z, depends upon the point without applying distance formula here. So the given points for case 3 are 1, 1, 0 to the point 1, 1, 1. If we are observing the points for x, for the first point you are having x is equal to 1. For the second point also you are having x is equal to 1. For both the points we are having the x value as 1, which are same. Next, moving to the second point, y. Y is equal to 1 in the first point, y is equal to 1 in the second point. If we observe, y is equal to 1 is also same for both the points. Moving to the third value, z is equal to 0 in the first point, z is equal to 1. If we observe here, z value varies from 0 to 1. Means this particular integral will be converted in terms of z. Your integral should be in terms of z so that you can substitute the z limits as 0 to 1. So since x and y have the common values in both the points, as x is equal to 1, y is equal to 1, we will be taking the derivatives dx is equal to 0, dy is equal to 0, since one derivative is 0 here. and we are having the z limits as 0 to 1. We will be substituting x is equal to 1, y is equal to 1, dx is equal to 0, dy is equal to 0 in the integral I3. On simplification, we get the equation as I3 is equal to line integral 0 to 1 8z square dz. We will be simplifying integration on applying the limit, upper limit minus lower limit. We got I3 is equal to 8 by 3. So as we have taken I is equal to I1 plus I2 plus I3, that is your equation 4. We will be substituting all the I1, I2, I3 in equation 4 and we get I is equal to minus 24. Here we have to remember that if the points are different, then you apply distance equation formula as method 3. If you are having the common points, if you are having 3 values x, y, z, and when you are having 2 points, see that 2 values of either x, y, y, z or zx, 2 values should be same and 1 value should be having different values. Where you are having different values, that particular value will be converted as limits. Where the values of x and where the values of y are same in both the points, that particular value can be substituted in your integration and simplify your condition. You will be getting the solution here.